Hello and welcome to our new course. Daylighting Design Guideline course will discuss guidelines and strategies for daylighting. A lot of these can be applied during early stage of design development and can be refined further as you go along. We'll focus a lot on thumb rules and basic approach to daylighting, which can then be further refined through simulation analysis and integrated with other design systems for lighting or dynamic facades. The learning objectives of this presentation are to enumerate what are the guidelines for overall building design, list the key strategies for daylighting shading which are integrated, and understand application in design through some very famous examples of buildings that have successfully demonstrated this. This course has 2 modules. We'll be covering daylight strategies for buildings and side lighting separately under each one of these things. This module, we will discuss guidelines that are applicable to the overall building design to ensure adequate daylighting and the daylighting principles that we want to achieve, which we discussed in the previous session. So, the first objective is to have optimal lighting without glare. We can derive an apt solution for any given problem if we have a clear idea of the intent. So, here the goal is to have sufficient amount of high quality light without glare, number 1. Number 2, to get enough daylight into the deeper areas, since typically there is too little light at the back of the room and too much near the windows or on the facade of the building. Next is to look at how do you reduce or prevent the severe direct glare from windows and skylights. This glare is aggravated if the walls adjacent to the windows are not illuminated and therefore they appear quite dark. So, you get a big contrast in your field of view. Another objective is to look at the optimal brightness ratio to prevent excessive difference between the very bright and very dark parts of your view. For example, what you can see in this image, this beam of light creates a puddle of light over on the wall, which creates this very dark and a very bright spot. It's also to prevent the ceiling reflection, which is created by overhead openings. So, very often when you have skylights, you can create, you will get a situation where there is a shadow over a book, or you get your reflection off of the ceiling into the task or into your desktop, which can create discomfort, visual discomfort. And finally, to maximize aesthetic potential of daylight in areas not assigned for critical visual task. So, which is another interesting function of light and daylight. To achieve these goals, it is necessary to start early into the design process right from the concept. If you look at the gift that we have of being in India, where most of the country, most parts of the country receive so much abundant daylight that it would almost be criminal to design a building that does not incorporate sufficient daylight, or where we are necessarily required to switch on lights during the daytime. The process of thinking about daylight into the space, especially for commercial buildings, for offices, for schools, for hospitals, for places where you require daylight throughout the day, is part of the first design intent, and it's true for any other passive means. So, if you look at a building that's thermally comfortable, if you want to look at integrating windows and openings for ventilation or for passive heating or cooling, then this has to start early in the design. But in order to do that, very often we have to look at what are the basic thumb rules, what are the basic design approaches that we can start off with. So, here I am going to start with strategies that are applicable to the overall building. Please note that these are high level design guidelines. These are appropriate to be applied when the building is, you are thinking about the form and when several options are available. So, these options can be incorporated further into design development through simulation tools, which will be available to you as you develop the overall form. So, that is the idea. The first aspect we are going to look at is building orientation, then we look at the form, space planning and color. The number one and the most important thumb rule is the north-south thumb rule. Determine the right latitude of the project, and this will help us figure out what is the right orientation. For northern latitudes, the south facade is exposed to the sun throughout the day, and the north is exposed to the sun in case you are in the southern hemisphere. So, this is crucial because it will tell us where to put the shade, what should be the predominant orientation of the building, and as you can see that the shape of the building, whether we want to make a building that faces more towards the north or the larger part of our facade faces south, will be dependent on where we are located. So, we must orient the building to maximize solar exposure during the day. This means orient the building to the north-south axis. During the day, the sun is at a higher altitude, and hence it is easier to control the direct radiation with the help of a simple horizontal shading device or a simple overhang. While during the monsoon and evenings, the sun is at a lower altitude, and hence the chance of a glare is very high. So, we want to orient the building where we are able to get maximum radiation, which is easy to manage and control in terms of shading. So, we get the daylight, but we can avoid direct sun into the space. If you do an orientation where the larger parts of the building, as you can see here, face east or west, then the rising sun or the setting sun are very low in their altitude, and you will get streaming sun into the building, and that's a very problematic situation, because to control the sun coming at that low angle, you will almost need to block it completely. You will need a screen, or you need blinds, and that will create problem with daylighting. In terms of building form, the most important aspect is how much floor area has access to daylight. So, the next rule is the 15-30 rule. In a typical design process, this yields a basic shape of the building, which says that for a space with ceiling of a height, say about 3 to 4 meters or 9 to 12 feet, whatever units you use, the area within the first 5 meters more or less, the first 15 feet from the window or fenestration will be completely daylit, and another 3 to 5 meters up to 15 feet beyond that can be partially daylit, where supplementary electric lighting will be required. Anything beyond that will have to rely on electric lighting. Now, this is the most optimum condition, given that you have a daylight window up near the ceiling and which reflects the light inside. In most cases, the basic thumb rule will be determined by the height of the window and the availability of shading device. but you can almost take it as a given that beyond 30 feet, with any of these systems, with beyond 10 meters, it will be difficult to get light from just one side from a window. So, if you look at a square shaped building floor plan, let's say this is a 10,000 square foot building with a with a 15 feet, as we said, as the daylight area, and the first 5 meters giving us that daylighting, you'll find that in this kind of a shape, 33% of my area, so excluding the central part, is partially daylit, and the central part has no daylight at all, right? If we look at a rectangular building for the same area, for the same floor plate, about 25% of the area has partial daylighting, but there is no area of the building that doesn't get any daylight. So, by introducing, by changing the shape of the building with the same area, you've changed the amount of daylight available for the floor plate or for the people in the space. And this can be further addressed if you want to go with a square shape by adding an atrium in the middle. So, if you create a light well or an atrium in the center of the building in a square plan or in any other plan where the areas are beyond 10 meters, in that case you can mitigate that, and this can be then be a much better daylight and almost eliminate the requirement for daylighting on a normal of electric lighting or for artificial lighting. The next thumb rule is for the design of atrium. So, atrium tends to have a common design element in a mall or in many other commercial buildings now. This rule we analyze and decide upon the atrium geometry versus the reflectance of wall, which will be effective in achieving the form of the atrium right during early design stage. So, an atrium is typically an enclosed space located either in the entrance of the building or in the center, and there are surrounding areas that look into the atrium. An atrium is typically public, and if you look at the geometry, reflectance and transparency, you need to understand a few key terms. So, these terms include the section aspect ratio of the atrium, the plan aspect ratio, and the well index ratio. The section aspect ratio is the ratio of height to the width of the atrium. It determines the sectional proportion, and with an atrium of this section aspect ratio of more than 2 is called a narrow atrium, and anything less than 1 is a shallow atrium. So, as you can see that the lower floor gets more daylight in case of a shallow atrium. The plan aspect ratio is the proportion of the atrium of the height and width in the plan. So, anything which is less than 0.4 is defined as a linear atrium. The well index ratio is the appropriate index for determining the effect of geometry on the daylighting and the efficacy of the daylighting. So, if the well index ratio is less, there is less wall reflectance and get enough daylighting till the forehead. So, if the well index is more, the wall reflectance should be increased to get more daylighting. So, as we get deeper and deeper, the importance of the surfaces that are around the atrium becomes more prominent. So, the moment we increase, we have a deeper atrium, we need more reflectance to get the same amount of lighting. The translucency offered by glazing material is also very important, because the top of the atrium is where the light comes from. So, the skylight on the right has a stained glass and it gets in much less light compared to one on the right on the left. Therefore, if we have the same amount of overall light that we want inside, we'll need a larger area in the second case. The next thumb rule is about daylighting guideline for a master plan. At an urban master planning level, when designing for efficient daylighting, these thumb rules will help us better planning of spaces between the buildings for effective light penetration inside our spaces. The first one is to have a dense urban pattern to reduce glare and direct heat in hot climates, and loose urban patterns in cold climates to allow direct sunlight penetration into the building. There are many ways to determine the street widths for given building height or vice versa. Though in most cases, the building height to street width ratio varies between 1:1 to 3:1 depending upon the climate and density of the site. Try to keep taller buildings towards east or west so that they cut off the harsh glare and from smaller buildings. Also try to house facilities with like storage and services in these buildings. The housing development, for example, here in Brunnerstrasse in Vienna is a perfect example of the main housing units are broken into smaller building units and face north-south, where on a long linear strip the buildings face east-west and that house all the services and ancillary services. So the concept of a solar envelope was developed by Ralph Knowles. It can be accessed for more sophisticated solar access at city level. So the solar envelope guarantees solar access to properties by regulating construction limits, and they are derived from the sun's relative motion. Buildings within the solar envelope would not shadow adjacent properties during the predefined period of time, and usually it's critical energy receiving periods during the years. These guidelines are especially effective in city planning level. So you can look at how the placement of the streets and the effect of the orientation and the distance between the buildings can have on the overall city planning. Colors play a major role in distributing reflectance of light, and you can refer to there are many texts and resources that are available that we'll talk about where you can understand more details, but the basic understanding of lighter colors reflecting more and darker colors to absorb more is something that we need to follow depending on the width and the issue of glare or light access. So it is better to use light colors both indoors and outdoors for better and deeper reflectance, but they could often cause glare if they are in our direct field of view from an adjacent building. So in this image you can see light colored walls reflect highly, but the dark color absorbs this, giving a very different proportion and sense of space.